right, let's do this. Let's jump right in. So we didn't quite get through the slides last time, so let's finish those up before we get into today's examples. We left off with list, and the most important thing here, aside from just the syntax, how to append to the end of a list, how to prepend to the beginning of a list. One of the most important things here was that you do have to reassign the value back to the original list. So this will create a brand new list with the values 2, 3, 4, and 50. But since it creates a brand new list and doesn't modify the list that we're working with, we do need to reassign that list back to our variable. So this doesn't actually affect anything until we reassign it back to list, which is what the lecture question was hitting on. Last time I saw the performance wasn't great on that lecture question, probably because it was rushed at the end a little bit. But you do have to reassign to your list to be able to see that change. Just like when you modify a string in JavaScript, Python, etc. When you modify a string, if you want to, say, concatenate two strings together, you have to reassign it back to your variable to be able to see that change. That change won't actually modify the list at all. In this case, creating a brand new list or a brand new string in the string example, and then you have to reassign it to your variable, or else you will not see that 50. If you don't have that, if you just do list append 50, you're never going to see that 50 in your list. It's not there. So when you reassign it back, that's when you're going to see the change. Now this list contains the list with 2, 3, 4, and 50. This list is going to contain the list 70, 2, 3, 4, 50. And then we will actually see those changes. But you have to reassign your list. You don't reassign it, those changes don't exist. Can arrays contain arrays? Can lists contain lists? Can maps have lists, arrays as values? Yes, yes, yes. All of that. You can mix and match types however you want. You can have a list of maps of arrays to arrays of lists of strings. You can mix and match these as much as you want. They can be infinitely nested. You can have a list of lists of lists of lists of lists as much as you want. And we usually don't do that much. At the point, because things do get messy. If we have a list of lists of lists of ints, like Nicholas put in the chat, it's just awkward to work with. It's hard to deal with data like that. We have a three-dimensional list at that point. It's tough to work with. Before we do something like that, we'll usually create classes, which is an LO2 topic. We'll talk about how to clean that stuff up, and by creating, say, a list of some new type that we create, and then that new type has a list inside of it, which might have more types and more lists inside of it. It helps us keep track of our code a lot better, keep things organized. A map of list of strings to array of list of double. Oh my goodness. Yeah, we don't like seeing that kind of stuff. And yeah, there are shortcuts here. If you see colon plus equals 50, that'll append. If you see colon equals 70 without this list at the end, that's the same as saying plus equals or minus equals times equals. You do have those shorthand operators available. When I show them in class, at least for now, I'm going to use the longhand way of showing things, but there are shorthands for these. All right, maps. Maps are our key value stores. These are your objects in JavaScript. These are your dictionaries in Python, your maps in Java, if you're coming from Java. A map is defaulted to a hash map. That's a 250 topic, but technically we're using hash maps. And these are going to be our key value stores, where instead of storing values at integers like arrays do, at indices, index 0, index 1, index 2, and that's how we access our values. Our key value store is going to store our values at whatever keys we choose. These maps will have two type parameters, and these type parameters can be different from each other. One type parameter for the keys and one type parameter for the values. So you can have a map of strings to ints, where the keys are strings and the values are ints. You have a map of int to double, where the keys are ints and the values are doubles. You could have, as we were just talking about, a map of arrays of strings to a list of maps of strings to ints. You can mix and match them however you want, but you'll have a type for the keys and a type for the values. We won't do that messy stuff, by the way. We don't. If that's too much, I agree, and we're not doing that. These can have variable size and variable values. You can change the values at any key. You can remove a key value pair. You can add key value pairs. You have a lot of flexibility with this. One thing that's still true, which is true in 115, is going to be true in any language that has a key value store, unless it's a multi-map. We're not messing with those either. You can't have duplicate keys. So you can't have the same key mapped to two different values. You can have multiple keys mapped to the same value, but you can't have duplicate keys. Because say you have duplicate keys, say I have a map where I have the key value pair 1, 2, and a map of int to int, and also the key value pair 1, 3. When I go to that map and I say, give me the value for the key 1, do I want it to return 2 or 3? Like, what's the map supposed to do there? What the map is going to do is, whenever you add a new key value pair, if it's a duplicate key, it erases the old value, and you only have the new value. So if I added 1 to 3 second, then that will be what's returned, the 3. You can't have duplicate keys. So it will overwrite your data if you add a duplicate key. The syntax, here's our second case of an arrow. Scala developers, the developers who wrote Scala, love these arrows. So to create a map, our two type parameters, I'm creating a map of ints to ints. So my keys and values are both ints in this example, and I have to give them key value pairs of int to int. To specify a key value pair, we use this arrow syntax. Key mapping to value. So the direction of the arrow makes sense intuitively. The key to maps to the value for in this map. So if I ask the map, what's the value of your key 2? It's going to be like, oh, it's 4. I got you. Separate your key value pairs by commas to initialize a map. If you want to add a key value pair to the map, plus sign. So take your map, add a new key value pair, and just like list, that is not going to actually add that key value pair to your map. What I have highlighted right here doesn't add the key value pair to 5 to 25 to the map stored in the variable myMap. It doesn't. What it does is creates a brand new map with that extra key value pair added to it. So this creates a brand new map with the key value pairs 2 to 4, 3 to 9, 4 to 16, and 5 to 25. And if we want to do anything with that new map that we just created, we have to assign it to a variable. So when I reassign it to my variable, that's when I actually get to see this change. That's when the change matters. Now my map has that key value pair 5 to 25. Without that reassignment to the variable, we might as well have done nothing. This is a very common mistake. That's why I'm spending a bit of time explaining it. Very common mistake to not reassign and then come to office hours saying, I swear I'm adding things to the thing, but the things aren't in the thing. Why aren't they in there? It's because you have to make sure you're reassigning to your variable. My map equals my map with this extra key value pair, creates a new map, and then assigns it to my variable. Oops, I'm trying to advance a slide. Accessing a value in a map, just like the syntax for arrays and lists, parentheses, and that's going to give you the value at that key. Now, this is actually a pretty dangerous operation, asking a map for the value at a key. This is the same as saying .get. Did I delete the .get example? I used to say .get. This is the same as saying mymap.get of 3. This is dangerous because if that key is not in the map, this program's going to crash. So you have to be careful when accessing values by their keys like this. If that value is not in the map, program crashes, and nobody's having a good time after that. In this case, 3 is a key in this map, so this is going to return 9, and that value x is going to store the value 9. If we did this with a value that's not in the map, so say we did 100 right here, program crashes because 100 is not a key in this map. So we have an alternative. If we want to get a value at a key and we're not completely sure if that key is in the map, we can use a very handy method called get or else. This is going to get the value at this key, or if that key is not in the map, it'll return whatever you give it as a second parameter, a second argument. It'll return -1. So here, 100 is not a key in this map, so we're going to hit the else of the or else and return -1. Very handy method when you're not sure. If it's in the map, I want the value at that key. If it's not in the map, just return this default value. Very nice to know. If you're doing country, city populations, give me the population of this city. If that city isn't in my populations map, return 0. If it's not a real city, just return 0 population for me. May or may not be helpful in the homework. That one actually I don't think you'll need on the homework. Homework 3, get or else, or no, go homework 2. Homework 2, get or else really comes in handy. And I'll flash back to this slide probably because there's a lot of questions every time about it. And then assign it to a variable, or value in this case, y. Y has the value -1. To iterate through a map, we have a few options. This is my favorite option. You do have mymap.keys, mymap.values. You have those methods in Scala if you want to just iterate over keys, just iterate over values. But Scala gives us this really nice syntax to iterate through both the keys and the values simultaneously. If I have that option with nice, clean syntax like this, I'm going to use it. Even if I don't need both the keys and the values, I'm going to use this syntax. In parentheses, a variable name for the key, a variable name for the values. I named it key value, but you can name these whatever you want. When we do test cases, I'll name these input and expected output. That'll make more sense on Friday. Whatever variables you want to name, and now you're iterating over 2 variables at the same time, being the keys and the values of this map. If you can iterate over keys and values like this, why would you do anything else? That's my argument. So I like to do it like that. If you want to do .keys, .values, go for it. Not going to stop you. But you have this syntax available for you in Scala. And the rest of the day's example, that was just cleaning up last lecture, but today's lecture is all about examples anyway, so it's all about examples today. But first, let's do this. Shit, I forgot what I'm doing. I'll go back to the question in a second. I just got to remind myself of what I ended up deciding. I did lay on factorial? Okay. We're doing factorial.
Yeah. The thing is, how do you want to do those things? So I don't have
I've lost 4 years of profit. It was way cheaper. I was thinking of buying it for 2 semesters. Okay, if I needed one more time, it would be worth it. Buying it all together. If I don't, I wasted the time.
All right, everyone good on the lecture question? Yes, you must reassign that map back to your variable. Anybody still submitting? Anybody need to see it again? Okay, let's do this. So for the rest of the lecture, we're doing live examples. Like I said before, Paul does most of his lectures like this. If you like this style that I'm about to do, go watch his videos. He does this almost exclusively. I don't think he even opens up the slides at all. So I'll do my first live example lecture. I'll do these fairly often, not as often as Paul, but today, like half of the next 2 lectures, and then next Wednesday and next Friday will be mostly examples like this. So let's do this. I have a problem statement. Let me give a bigger overview too. I have a problem statement that I want to write. I want to write a method named factorial. It's going to take an int, return an int, and the int it returns is the input factorial. And then I want to run this code and see what it ends up doing. So for this method, we'll write the method. I'll write it in IntelliJ, walk you through my thought process and how we're coding this. And then I'm going to do my first memory diagram for this semester, for this lecture. So memory diagrams are going to be a way that we draw out exactly what's happening in memory as this program runs. And we're going to focus on what values every variable is storing at every step of the way, plus a few extra topics that I'll explain when we get to the memory diagram. I mentioned this before, but Paul has been doing these memory diagrams, I think, since the first coding example he's ever showed. So if you want more practice with these, check out his lectures. I'll be hitting these pretty hard today, next Wednesday, and next Friday, though. So you will get examples from me in this lecture as well. This is what you will be asked to do on the quiz. So when we get to that quiz on week 4, that first quiz, every quiz will be like this. You'll be given a piece of code, and you'll be asked to draw the memory diagram. So these are very, very strictly important that you understand how to draw these things. So first, let's do the code, and then I'll draw the memory diagram for the code. So let's start this. Anybody know how we would want to start this? Well, I guess I'll get the header. That part's easy enough. Factorial. I got to cover my cheat sheet. Returns int. So this method named factorial takes an int, returns an int. Most of the tasks in the homework are worded just like that. I tried to word this the same as the homework tasks. Takes an int, returns an int. That's saying this is the type of the parameter or parameters, just one in this case, and the return type. If it returns an int, that should be your first thing. You know how to write that first line. A method named factorial that takes an int as a parameter and returns an int. I know my signature for this method, and I can type that before I even know what this method is supposed to do. In this case, it's self-explanatory. It computes factorial. But if it's not, before you get to your code, you can write that right away. Now for homework 1, those are all filled in for you anyway. But in later homeworks, they won't be. You have to write your own methods. And that first line in the description is meant to help you write that header. What are the parameters? What's the return type? Okay, this method should compute the factorial of the input. Before I even get started with that, I'm going to write a main method that's going to call this method so I can have an example of running this code. This is the first and only time you'll see me do this. After Friday's lecture, we're going to use formal unit tests for this, but I will show one main method here. And as we know, just type main, enter, and I'm going to say val x. Yeah, I'll name it x. Of type int equals factorial of, let's say, 5. And I'm going to print x to the screen. Now, my brain's a little slow sometimes, so factorial of 5, 120, right? I think it should be 120 expected. We expect 120. 5 times 4 is 20, times 6 is 120. Okay. Maybe I should review that just in case somebody's like, wait, what's factorial again? It's all the values from 1 up until that value times together. So 2 times 3 times 4 times 5. And I have my little shorthand. 4 times 5 for 20. 2 times 3 is 6. So 6 times 20 is 120. All right. So to write this, I'm going to have a similar setup to task 1 of the homework, where I'm going to initialize a variable that's going to have my answer in it. I'll even call it answer again. That's going to be an int, and I want to initialize that to something. I'm going to eventually return that. So I want to initialize a variable, do something, and then end up returning that variable at the end. And the question is, what's this something we're going to do, and what are we going to initialize this as? So the something in the middle, let's get everything on screen here, at least for the moment, is looping through. I want to loop through those values from 1 to n while multiplying those values to answer. So I'm going to say for I, the universal loop variable, and there is no other choice. For I in 1 to n, I want to iterate over the values. 2 is inclusive of the endpoint, so this will loop 1, 2, 3, 4, 5, and in this case, n will be 5, and then stop. It'll iterate over all those up to n. Then answer. Did you see this shorthand in 115? Is everyone familiar with this shorthand? Can I start using this? This star equals or plus equals, or like I mentioned earlier, colon equals, and was in chat. Is everyone good with this? I can explain it quick. I'll explain it quick anyway, but I just want to know if I should start using this or if I'll have to expand it. So that's equivalent to this. So these are equivalent statements. Either answer equals answer times I, or answer times equals I. It's just a shorthand. A lot of languages incorporate this, have this in their syntax. It's just saying, we don't want to make you write answer twice, is all it's really saying. I'll actually stick with this today, now that I think about it for a second. I don't want to, just in case that's new to a lot of you, I don't want to throw too much at you at once. I already did that in the past few lectures. There was a lot. Let's not do more syntax than we have to. So this is going to iterate from 1 to n. I want to say 1, whatever answer is, multiply it by 1. Whatever answer is after that, multiply it by 2, then multiply it by 3, then multiply it by 4, then multiply it by 5. end the loop, and then my last expression in this method is going to be just this variable, whatever's stored in this variable, return it. Our only question still is, what are we initializing this thing to? Yes. 1? All right, let's do it. 1. So there are a handful of choices here. Just make sure you're thinking about your problem statement as you're initializing. We can't initialize answer to 0 here, because then we have 0 times 1, which is 0, times 2, which is 0, times 3, 0, 0, 0. It's all going to 0 out. So we want to make sure we're using the multiplicative identity here. If we were adding all these values, we want the additive identity. We want 0. Just be careful what you're initializing things to. Mostly we want to do 0. This is a case where we want to make sure we initialize that at 1. And then if we happen to be computing the factorial of 1, it's just 1, 1 to 1, 1 times 1, still 1, and then we just return 1, which is what we want to return. So let's run this. Make sure we get our 120. Then we can get to this memory diagram. Oh, no. That's not even. So since Scala is a compiled language, it's looking and compiling all of your files whenever you want to run anything. So if you have an error in a different file that's not even remotely related to what you're working on, like what just happened there, it's not going to run your code. Some of you may have seen this before. Some of you have brought these to office hours before with that problem. Everything has to have, doesn't have to be right, but everything in your project has to not have compilation errors. So I had a compilation error there. I wasn't returning a return type. It was a method that was supposed to return a double, but the method just had an empty body. So it was expecting double, got unit, which is Scala slang for nothing, and it wouldn't compile. But now that it did compile, I got my 120. I expected 120. Feeling good about that. Okay, any questions on the code itself? Most of you have finished task 1 on homework 1, so I assume this is a step down in difficulty from that. I think that's safe to say. Everyone should be good on the code itself, right? Any questions on this? Of course, now you can't ask a question after that preface. Like, he just said I should know this. Yeah, you can call. So I'm just running. So I ran this file specifically. I'm running the factorial file, and I'm just running that part of the code. But whenever you run any of your code, Scala will compile everything. Not necessarily run anything. This is the only thing that's being ran. Even though I'm in the examples repo with a whole semester's worth of examples, this is the only thing that's being ran. But during compilation, it's going to make sure I don't have any errors anywhere else in the code. If I have errors anywhere in some LO4 example that I broke, it wouldn't let me run this code, even though they're completely unrelated. Just the way compiled languages work. It's compiling everything, and we can't get away with any errors. Okay. Now to some new stuff. Memory diagram. And I wanted to keep this example pretty concise for your first memory diagram example, which I just wrote during the lecture question. So I didn't use this as my cheat sheet. So what we want to do is trace through this program. And by the way, I don't really want to use this document camera, but I don't have a good way to do this electronically yet. So at least today we'll have to deal with my handwriting. I don't think it's too bad. I think Paul's might even be worse. But we'll deal with the document camera for today at least. Oh, and I couldn't put chat right on the screen, I guess. Can we get chat in the video? We don't need to. And I have to be self-conscious about my hands, but we'll get through this. So to draw a memory diagram, let me draw it this way. we're going to separate our memory diagram into two things called the stack and the heap. For this example, we only need the stack. So I'm going to draw the stack significantly bigger than the heap. These are two different types of memory. I'll explain this in more detail when we have an example that uses the heap. But for now, we're going to use the stack. The stack is where all of our variables are stored. The stack we're going to separate into two columns. Name and value. So everything on the stack is going to be either a variable or a value. I'll use a variable or value interchangeably in most cases, whether they're val or var. Just because I get sick of keeping them straight. I have a val and a var here. I'll call them both variables. But both of them, what they'll have in common is they'll have a name and they'll have some value assigned to them. So when we trace through a program, whenever a variable is declared, we're going to add it to the top, to the bottom of the stack, bottom visually, top conceptually. And we're going to add that variable to the stack and keep track of its value. And if that variable updates its value, we're going to update it on the stack. So the very first thing, we always start with the main method. That's where Scala programs start. And we hit a value named x, which is going to be assigned the value, which is the return value of this factorial of 3. And now I'm immediately regarding that putting a simpler just val x equals 7 before the method call. Is it too late to change? Yeah, it's too late to change. Yeah, we're going to call that too late to change. So we're going to put x on the stack, but we don't know the value of x yet. The value of x is going to be whatever this factorial of 3 returns. So when we call factorial of 3, when we have a method call, and by the way, I realize this is going to be a lot right today. We have 2 more lectures next week to hammer down all these details and talk about it a lot more. But I want to get the first example out there with a bunch of this stuff. So when we call factorial of 3, we're going to create what's called a stack frame, which hopefully is familiar from the syllabus, from the learning objective section. We're going to create a stack frame whenever we have a method call. Technically, there's a stack frame for the main method. We're not going to draw that because that's just the whole program. So when we create a stack frame, we're going to put a box on our stack. And it's going to be careful to make sure it's big enough for exactly. I'm kind of looking ahead to see how much room I'll have. If you just don't draw this bottom line until you're done with your stack frame, that's perfectly fine. If you don't know exactly how much room you'll need. So when I create this stack frame, this is a separate part of the stack. It's a separate portion of execution that can't access anything outside of the stack. So you know by now when you have a method, when you write a function or a method, you don't have to think too much about the variable names in the sense of I can reuse variable names. If I had this as val n, when I'm writing my method up there, I can reuse n because that method call is going to happen completely separate from any other method call or any other frame on the stack. So this, we draw a box to denote that this is a method call. It creates a new stack frame, and it's completely separate from the main method call. We're going to draw a little arrow here, boop, and that's going to say when this stack frame, when this method returns, it's going to give its value to that variable x that we declared, that we put on the stack. And we're going to annotate this to say what's running here. This is a call of the factorial method. So I'm going to label that as factorial to say this stack frame is a call of the factorial method. Whenever we have a method call, let me add this before I forget. We're also going to have a section for inputs and outputs. In this class, we'll only have outputs, but for what's printed to the screen, you have to write that in your quizzes too. What's printed to the screen throughout the execution, which we'll just have one thing at the end here. And there's nothing below that. It's just a new section. The very first thing that happens on the stack when we call a method is we put the parameters on the stack equal to the values of their arguments. So if you took 115 with Dr. Alphonse, I know he hammered this in your heads, but the difference between parameters and arguments, parameter, when you define a method, n is a parameter. 3 is an argument. Arguments are when you call a method. So when a method is called, you set the parameters equal to the arguments. We throw those on the stack, and we have n with a value of 3. Always the first thing you do when you have a method call is put those parameters on the stack. I don't know how many times I've seen students not put their parameters on the stack and then get completely lost on these things. Put your parameters on the stack. Next line, we have a variable answer equals 1. And then we're going to enter a loop. Whenever we enter what we call a code block, which in short is any time we have parentheses that are not parentheses for a method, braces that are not braces that define a method body, we're going to enter a code block. So for our purposes, this is loops and conditionals, or if statements. We're going to go on the stack and draw, oh my goodness, I can't do this, and draw a box similar to our stack frame, but as a dotted line. Whenever you enter a code block, this behaves a little bit differently than code that's not in a block, in that any variables that are defined in a code block are removed from the stack when that block ends. So we denote this using a dotted line to remind ourselves, hey, we're inside a code block. And then when we get to the end of that block, that dotted line is gone along with any variables inside of it. We have one variable inside of this one. It's I, our loop variable. And it's initialized to 1. It's a terrible looking one. Almost looks like a 2. I promise that's a 1 with a hat. Now we start looping. So as we go through this loop, right here. So as we go through this loop, we're going from 1 to n. What's n? We're not tracing through our code. We're not looking at factorial of 3. We're not doing any of that anymore. What's n? We look at our stack. Look at our memory diagram. N is 3. So we know that we're going from 1 to 3 in this loop. It's 2, so it's inclusive of the endpoint. So we're going to hit 1, 2, 3 in this loop. So 1, right now, we're going to do answer times equals I. I'll do this in black. Answer times equals I. So answer times I equals answer. And I did do the shorthand because I wrote this before I thought that through. You have to deal with the shorthand right now. So whenever I have a variable that updates, whenever I have an assignment to a variable, we're going to cross it out, and we're going to write the new value. Now in this case, the value itself didn't change. We're still going to cross it out and write it to show that there was a reassignment. That way when the TAs or myself or Paul are looking at your quizzes, if you have this, we know you did the right thing. We know you know what you're talking about. And we can give you credit for that. Make sure you're still crossing out whenever you have an assignment. We reached the end of the loop. We're going to go back to the top. We went to 1. I've mixed. Since I'm putting hats on my 1s, I better put them on all of them. We're going to go back to our loop. We hit 1. We're going to go to 2, and we're going to cross out our I. This goes to 2. Answer times equals I. Answer is 1. I is 2. Answer equals 1 times 2. Update the value. We're going to cross out the old value and add in the new value. We hit the end of our for loop, go back to the top. We're at 3. Answer times equals I. Answer 2 times 3 equals 6. Cross out our value and update. Write the new value. Now we've reached the end of our loop. We did 1, 2, all the way to n. When we get to the end of a code block, cross it out. At that point, right after the for loop ends, that variable I no longer exists. That's part of the loop. Doesn't exist anymore. If after that for loop I say print line I, I'm going to get an error, variable not found. This is something you found, at least intuitively, kind of practically in 115 or wherever you took your CS1, where if you create a variable inside a loop and then you try to return that variable outside the loop, you get an error, you pull your hair out, you go to office hours, you try to figure out what's going on, and you finally realize, oh, the variable, I can't do that. I need to declare the variable outside the loop, and the TA would probably be, or the professor would probably just say, you got to declare your variable before the loop starts, and then it just works. And you're like, okay, I guess that just works. What's going on there is when you hit the end of a loop, any variables declared within that loop, including the looping variable itself, I in this case, destroyed. So if the first line of the loop said val y equals 21, that variable is off the stack once that loop ends. So I no longer have access to it. It no longer exists. That code block is gone. We also hit the end of our method. We hit answer, which is going to be our last expression that's evaluated. We hit the end of our method. We cross this whole thing out. Answer is 6. 6. Then the last thing we do, print line X. We go over to our in-out section, and 6 is printed to the screen. Yes, you should all be bringing colored pens to the quiz. Or crayons or colored pencils would work too. I'd be happy to see something in crayon. The quiz is going to be done on paper. The specific details of how to hand it in are a little bit up in the air right now, as we got to figure out the easiest way to do this. But it will include a paper submission. You'll do it on paper and then hand into the TA. There may also, depending on how it works in the first few labs, we'll have you take pictures of that and upload a PDF to Autolab. I have a feeling that's going to be a mess, and the TAs will end up doing the scanning. But we want electronic copies on Autolab at some point. Who's doing it? You or the TAs? That's still up in the air. But you will be doing these on paper, which is why it's good I have at least one on paper right now. And yeah, as Nicholas said in the chat, the colors are just to make things a little more clear, especially for lecture, not required on the quizzes. You don't have to do different colors, which I can see the colors don't really even show up that well on the camera up here. When is our first quiz? Week 4. So for grading, we're going to review the completed one. So looking at this, we can tell if I went through this program the right way. Just by looking at this, I can see, I mean, it's possible you made a mistake somewhere in here, but it's unlikely. Usually if you make any mistake that indicates you actually don't know what's happening when this runs, everything's going to be wrong all over the place. So if we see something like this, there's like a 99% chance that you knew everything and you did it properly. Just by seeing what's crossed out, are all the values the right values that are crossed out? Are the right stack frames there? Are the right code blocks there? Do you have everything labeled the right way? If you have all that, then it's going to be good. It's not going to be somebody over your shoulder watching you do it and making sure you did everything at the right time. Mostly just because we don't have the resources. We don't have enough TAs to do all that. Remember, the TAs are going to be doing interviews during this time too. We don't have time to look over your shoulder and watch you do it. Yeah, so the big box we crossed out. We crossed this out when the method ended. Just like a code block, whenever a method ends, everything that was declared inside that method call, n, answer, I was already gone, all those are removed from the stack. They no longer exist outside of the method call. When we go back to the main method, the only thing that exists is the value that was returned. There's no other memory of that stack frame ever existing in this program after that stack frame ends. It is removed from memory. It's no longer on your RAM. It's gone. We practice diagrams in the next lab, right? Yes. Next week's lab is all about practicing this. Next week, Wednesday and Friday are all about practicing this. And then after next Friday's lecture, that's the actual quiz itself in lab. So we got to get you ready for it by then. You have to be able to draw these. Given a piece of code, this is what the lab's like. You're given a piece of code, and you have to draw all this. Except with more complex examples. This is just the first one you see. See you Friday.